Hello friends, you are watching channel number collage. The purpose of this channel is to take sincere efforts to make you understand and like mathematics, science and engineering in a simple and easy manner. In this video, we will discuss more problems on centroid of composite section. Determine the coordinates of the centroid of a thin plate like this whose various dimensions have been given, in which a hole of diameter 120 mm is cut. We will find area of the section. Area of rectangle A1 will be 190 multiplied by 160, which will be 30,400 mm square. So this is A1, area of rectangle. Area of circle, whose radius will be 60 millimeters. So A2 will be pi r squared. R is 60, so it will be pi multiplied by 60 squared, which is 11,304 mm squared. So this is A2. Area of triangle, this triangle, A3 equals half multiplied by base multiplied by height, which will be 4,500 mm squared. So this is A3. Area of section will be A1 minus A2, which is the area of circle, minus A3, which is the area of the triangle. So we have A1 equals 30,400 minus A2, which is 11,304. So we have to subtract this area and subtract 4,500, which is the area of the triangle. So this area is subtracted. So we are left with area of the section as 14,596 mm square. So A is 14,596 mm squared. We will find moment arms of the centroids of different subsections from y-axis. First of rectangle, which will be x1 equals 190 divided by 2, which is 95 millimeters. x1 95 millimeter. Next of circle, x2 is 80 mm. Of triangle, it will be x3 equals 90, which is this distance, plus 2/3 of 100 mm, 2/3 of this 100, which will be 156.66 millimeters. So x3 will be 156.66 millimeters. Moment arms of the centroids from x-axis, which is this, of rectangle and circle, this rectangle and this circle, y1 equals y2, which will be 160 divided by 2, which will be 80 millimeters. So y1 and y2 will be 80 millimeters. of triangle. So this is the triangle. Y3 will be 80, which is this 80, plus 2/3 multiplied by 80. 2/3 of this 80. It will be 133.33 millimeters. So this is Y3. Calculation of X bar and Y bar. Values of A1, A2, A3, X1, X2, X3 and Y1, Y2, Y3 have been provided here. We have, for calculation of X bar equals A1x1 plus A2x2 plus A3x3 divided by A1 plus A2 plus A3. Substituting the various values and evaluating, we get X bar equals 97.28 millimeters, which we show like this. Calculation of Y bar for this section. We have Y bar equals A1Y1 plus A2Y2 plus A3Y3 divided by A1 plus A2 plus A3. Substituting the values and evaluating, we get Y bar equals 85.19 millimeters. We have already found out X bar equals 97.28 millimeters, and here, which we show like this, and Y bar equals 85.19, which is this, which we can show like this. So we have the position of the centroid of this section G 97.28 mm, 85.19 mm. A plane area with its various dimensions have been given here. We have to determine the coordinates of the centroid of this plane area shown here. Next, area of semicircle. This semicircle A3 equals half multiplied by pi r squared. We have r equals 200. So A3 becomes 62,800 mm squared, which we show here. Area of corner rectangle. This corner rectangle A4 equals 200 multiplied by 200, 200, 200, which is 40,000 mm squared, which we show here. Area of triangle, this triangle A5 equals half multiplied by base, which is 400, multiplied by height, which is 300. A5 is 60,000 mm squared, which we write here. Moment arms of centroids represented by these areas from y-axis. x1 equals x3, which will be 800 by 2, which will be 400 mm. x1 is for rectangle, x3 is for semicircle. x2 equals 4r by 3 pi, where r is 200. x2 will be 84.93 mm, which we show here. x4 equals 200 plus 400 plus 200 divided by 2, which will be 700 mm, and we show it here. x5 equals 200 plus 400 plus 200 plus 1/3 of 400, which will be 933.33 mm, and we show x5 here. Moment arms of centroids represented by these areas from x-axis. y1 equals 800 divided by 2, 600, 200, 800 divided by 2, which is 400 mm. So for rectangle it is y1 400 mm. y2 equals 600 plus 4r divided by 3 pi. R is 200. It will be 684.93 mm, which we show like this: y2. y3 equals 4r divided by 3 pi. This is for this semicircle, where r is 200. y3 is 84.93 mm, which we show like this. This is y3 for semicircle. y4 equals 300 plus 300 plus 200 divided by 2. It will be 700 mm, which we show like this: y4 is 700 mm. y5 is for triangle, 1/3 multiplied by 300. It will be 100 mm. So y5 is 100 mm. All necessary values for the calculation of x bar are provided here. Calculation of x bar. We have x bar equals a1x1 minus a2x2 minus a3x3 minus a4x4 plus a5x5 divided by a1 minus a2 minus a3 minus a4 plus a5. Substituting the values and evaluating, we get x bar equals 450.71 millimeter, which we show like this. Calculation of y bar. The necessary data is provided here. Let us calculate y bar. We have y bar equals a1y1 minus a2y2 minus a3y3 minus a4y4 plus a5y5 divided by a1 minus a2 minus a3 minus a4 plus a5. Substituting the values and evaluating on calculator, we get y bar equals 330 32.88 mm, which we show like this. We have already calculated x bar, which was 440.04 mm, which we show here. The point of intersection of these two lines indicate the position of the centroid like this. So the position of the centroid is located at G, which is 440.04, 332.88. There are 6 holes of diameter 22 mm. In a gazette plate as shown. Find the position of the centroid of this gazette plate. To find area of this section, first we will find out areas of the subsections. First, area of rectangle. This rectangle, which is AR equals 170 multiplied by 320. It will be 54,400 mm squared, which we represent by AR here. Area of triangle, this one, 80 equals half base, which is 320 multiplied by 60, this height, it will be 9600 mm squared, which we represent by 80 here. Now we will find area of one hole. AH equals minus pi r squared. We have introduced a negative sign because this area is to be subtracted, which is minus r equals 11. So it will be minus pi 11 squared, which will be minus 380 mm squared. Area of one hole. Now these areas are to be subtracted. We will find moment arms of the centroids represented by the areas of different subsections. First, from x-axis, from here. First of rectangle. So distance of centroid of rectangle from x-axis YR will be half times 170, which will be 85 millimeters, and which we show here. Next, distance of centroid of triangle from x-axis. This is the triangle, which is this one. YT equals 170. This is 170 plus 1/3 of 60. This height is 60. 1/3 of that. That will be 190 millimeters, which we show here. Now we will find distances of the centroids of the holes. First, y1 equals 130 millimeters, which we show here. y4 equals y5 equals y6. That is, the distances of the centroids of these three holes, 4, 5 and 6 will be same, which is 60 millimeters, and we show it here. Y2 is the distance of the second hole, 140 millimeter, which we show here. And finally, distance of the third hole, which is 150 millimeters, which we show here. Now we will find moment arms from the y-axis of this section. From y-axis, first of rectangle, this rectangle, XR equals half multiplied by 320. Now 8 4s are is 320. So half of this, which is 160 millimeters, and which we show it here. Off triangle, this triangle, which is this one, xt equals 2/3 multiplied by 320, because this distance is 320 and 2/3 of that will be 213.33 millimeters, which we show here. Distance of first hole and fourth hole from y-axis will be same, which is 80 millimeters, which we show here. Distance of second hole and fifth hole is 160 millimeters, which we show here. Distance of third hole and sixth hole is 240 millimeters, which we show here. Various values required for the calculation of x bar have been provided here. For calculation of x bar, we have this formula. Substituting the values and evaluating, we get x bar equals 168.29 millimeters, which we show like this. Here also, the various values required for the calculation of y bar have been provided here. For the calculation of y bar, we have the formula. Substituting the values and evaluating, we get the value of y bar equals 100.77 millimeters, which we show like this. We have already found out x bar equals 168.29 millimeters, which we show here like this. The point of intersection of the lines of x bar and y bar intersect at this point, which is the position of the centroid of this section, which we show by G 100.77 millimeters, 168.29 millimeters. So this is about centroid of composite section part 3. If you like this video, subscribe this channel to get more videos like this. Share this video with your friends and relatives. Thanks for watching. Keep watching Number Collage.